Hello, everyone. Welcome to my talk about the future of software development. And yeah, before we start, a few fun facts about me. I've been in the IT and mostly in ML for more than 10 years now. I've been building the Encoder, AI coding agent solution, since day zero. And for the last year, I've been mostly doing DevRel. And this one is my event number 34, which also resulted in quite a lot of flights. And I have 4 main coons who are waiting for me at home in Portugal. And yeah, sometimes I do visit them between the flights. Now, before we go into the talk, I would like to know your opinion. Will AI replace developers? Can I get a show of hands who think that AI will replace developers? Okay, a few people think that AI will replace developers. Okay, well, I actually asked ChatGPT, GPT-5, if the AI will replace developers, and it said no, of course, but it's AI, so it wouldn't give away its plans, right? But also, you might have seen quite a lot of headlines, like this one, for example, where Mark Zuckerberg said that AI will soon replace developers, and in this case, he predicted that this will happen by 2030, and it will replace mid-level engineers. Now, all those predictions are usually doesn't come to life, right? At least in the same time frame which was predicted. Like here, for example, with the self-driving cars. But I think that self-driving cars is a good analogy with what is happening in AI in development and in software development. And if you are not familiar with different levels of self-driving car autonomy, I will use them throughout this presentation. And they basically go from level 0 to level 5. With the full automation, and they basically introduce more and more automation into the self-driving cars. And as you might have guessed, this image was generated by ChatGPT, so it didn't learn how to center diff as well. Now, if we sort of use the same analogy and apply this to software development, we can end up with the following 5 levels. And I will skip, obviously, level 0, which is no automation at all. And we will start with level 1, right? And this is where essentially GitHub Copilot was first introduced. And it was essentially just a LLM wrapper, right? It was able to answer your questions, sort of like a Stack Overflow on steroids. And it was able to complete your code. Sometimes it did produce some weird results because it wasn't aware of the sort of nature or biology or physics of the real world. It was able to detect patterns, but it wasn't able to apply them to real life. But we all know how AI is with hands, so it's not surprising. Right. So the wrappers are already produced some improvement to your quality of life, to quality of life of developers. But of course, going forward, we started to introduce some feedback. So LLM started to get some feedback from syntax. So let's say when you use your IDE, VS Code or JetBrains, you sometimes get with sort of curly highlights, right? So when you have an error, when you have some issues, warnings, and whatnot. And we could use this to guide LLM when it generated the code. So the LLM would generate the code. It would get some sort of feedback from the IDE that these methods are not defined, or maybe there are some warnings. And it could iterate on top of this to give you a bit better results, right? And they are all great. So they can generate code, they can detect errors, they can generate documentation. You can tap, get a bunch of code, and then spend some time on debugging it. But unfortunately, they are LLMs. They are still based on LLMs, and LLMs are trained to predict most probable next symbol or token, right? And these sometimes lead to errors. So you've already seen this 300 case where it was able to detect pattern. But obviously, it doesn't rely to real-life world, right? And the same goes if you are using this with your own company framework, right? So LLM, because it's not grounded to your company, to your physical world, it doesn't know anything about your company's framework, so it wouldn't be able to help you. Yeah. So with that, we will go to level 3. And this already starting to become interesting. And we got here probably like late 2024, early 2025, so this year. And this is where we started to see AI agents, right? So here I call it this level 3 junior software agents. And they already start to go beyond just getting syntax feedback. They start to be able to use compilers, for example. They start to be able to generate unit tests and leverage that to get much better feedback. So they wouldn't just generate the code. They would, for example, try to run it, try to compile it, make sure that it works, that it compiles. And if it doesn't, it will use the errors to update the code, right? And those improvements are based on two main things. First of all, of course, models are getting better. And here, for example, are benchmarks for the latest models from private laboratories, like from Google, from OpenAI, and from Anthropic. And you can see that, of course, models are getting better and better. And here, specifically, I highlighted two code-based benchmarks, SV-Bench and either Polyglot. And models are getting better at producing code. But the code itself, those benchmarks themselves, they are not really translatable one-to-one to real-life world, just because the tasks in the benchmarks are not really the same you would see in the real-life world, right? So, for example, either Polyglot requires the model to just fill in one method, whereas in the real-life world, we usually modify multiple files, we modify multiple repositories, so they're not really a one-to-one approximation of real-life world. But still, it's a good proxy to see how LLMs are getting better and better. Now, the second part, and which was actually in the name of the level 3, is AI agents, right? And you probably heard a lot about AI agents already on this conference as well. But let's just so that we are on the same page. So we can define AI agents as software that follows the following design patterns or design principles. First of all, it can use tools, right? So LLM is able to use any tools you give access to. So it could be, again, compiler, it could be running unit tests, it could be web search, it could be pretty much anything, like file system as well. And it can use it to gather more context, more information. And based on this context, it can then give you better results. It can also do planning. So instead of just simply outputting the tokens, the text, it can do some planning. So you might have, if you used GPT-5 or Claude Sonnet 4, you might have seen its sort of thinking process. So essentially, before giving you the answer, it would first sort of think through or plan what it needs to do, right? And then it will give you the actual answer. They can also reflect. So again, going to GPT-5 or Claude Sonnet 4, sometimes it would sort of think in the middle of the answer, reflect on what it produced, what it came up with, and then maybe change its trajectory. It might update the answer and so on. So basically, they can reflect on their work. They can reflect on each other. And this is also where multi-agent collaboration comes in. So agents can also interact with each other, right? So they're not necessarily just some entity which lives somewhere on the cloud. They can talk to each other potentially, right? They can also critique each other, so they can reflect on each other's work, collaborate, and so on. So basically, they pretty much like humans. They can help each other, or sort of fight with each other, if you will. And you can see the effect these agentic patterns have on the model performance on this slide. So for example, on this benchmark, Humanities Last Exam, if you take GPT-5 without any tools, without any thinking, we will get 6.3% over here. So it's just vanilla LLM running, trying to answer some questions from the benchmark. But once we get the planning step, once we add the tool use, so in this case it's just Python and the web search, you can see that GPT-5 got a boost to 35%. So essentially, almost 30 percentage points it gained just through essentially two things: tool use and planning. So you can see already how agentic patterns can boost significantly the way models can perform. And if we translate this to sort of our programming world, here's a good example, right? So let's say we have a task to update website designs based on updates in Figma. And the way it would look like in agentic world is the following. So the agent first obviously can decide to get the designs. So pretty much like we as humans do, right? So we get the designs. For that, we use tools like Figma. Then it needs to do some planning. And it needs to find the files that needs to be updated. It will generate the code. And then it can potentially run the updated website. Again, through the tool use, through the browser. It can take the screenshot of the page and then do some reflection, right? So it might compare the screenshot to the Figma design and see if they're different and how they're different. Then, based on this reflection, it will try to repeat this step of coding, and then basically do this over and over until it decides that it is done. It might also decide to run the tests, again through, for example, Playwright, which is another tool. And then this loop continues until it is successful, or at least it thinks that it is successful with the task, right? And it looks pretty much like we as developers work, right? So we as developers use tools. We hopefully do planning. We reflect on our work, on work of each other, and we essentially are, in a sense, behaving like agents, or rather, agents are behaving like us. And this is sort of what we've been seeing for the last half a year, right? So in the tools like Cursor or us and Coder, right? So you could have agents working on your behalf using tools, again, through like Figma, browser, whatever you gave them access to, giving you hopefully better results. Although sometimes, of course, it leads to a bit unpredicted cases, right? So when you've probably seen cases where some tool would drop the database and so on. So obviously, there are some dangers coming there. Now, in this case, in the case of level 3, we have the tools which are essentially deterministic, right? So they are just the function calls. And of course, whenever you call a function, it usually is deterministic. So when you run it, you get the same answer over and over. Now, imagine if we, instead of tools, have agents. So basically, we will go then to level 4, where we will have what I call here a mid-level agentic system, or where we have multiple agents working together in order to achieve better results. And again, they are working across, your, for example, CI/CD. They are working across your UI, UX, and so on, your databases. And they can work with each other to, again, give you better results. So you get basically more focused agents working on specific tasks on your behalf as part of your work. So pretty much like your cross-functional agile team would work on different tasks, right? So you would have a front-end developer, you would have back-end developer, or maybe DevOps engineer, and they are working on their specific tasks. They have specific skills, and well, their work, I guess, also not very deterministic, right? So front-end developers would not recreate one-to-one the same task if they would have been asked to. And you can have, so basically, again, instead of tools, here you would have agents, and you would get another level of abstraction, kind of. So this user here would be an agent, which is calling other agents. And then those subordinate agents will decide which tools to use, and so on. And there are different levels of how you can define this multi-agent architecture, right? So you can have, as I mentioned, supervisor agent, supervisor schema, pretty much like we have in our cross-functional teams, like we have product manager, and we have subordinate agents, subordinate developers. You can have some hierarchy. You can have agents all talking to each other without any subordination. You can have some custom, sort of random interaction. Now, the issue here is that while, as I mentioned, agents are non-deterministic, right? So you're not always guaranteed to get the same result. And also, if you used agents in your everyday life, you might have seen that sometimes they get into the same loop over and over, so they kind of get stuck. So imagine an agent getting stuck, let's say this one agent getting stuck. So obviously, this will sort of hinder the progress of the whole system of multi-agents. So there are some things to keep in mind if you want to use this multi-agent system. Now, let's see actually how it would look like in real life. So first of all, there are actually two ways for us to do this, and I will show two ways. So first one, if you were to implement this system on your own, here's one example. So I won't be going to much of the details of the code here, but essentially I am creating a supervisor schema, and I will share the link to the actual code in a second. But basically, what I have here is a supervisor schema of multi-agent system, where we have a sort of product manager or supervisor, and it has under its command 4 subordinate agents. So backend, frontend, DevOps, and QA. So essentially, I'm kind of recreating the cross-functional team here. And the prompts are pretty simple. So I'm just asking the supervisor to create a plan, assign each task to a specific agent, and then transfer this task to that agent. And the same with all the subordinate agents. They are the prompts are pretty simple. They are, you are backend engineer, backend developer, implement, and then go back to prompt engineer. Oh, sorry, to product manager. And I've actually ran this before the presentation. So the task they had was to build a website for the conference. And it should have 3 pages. It should have front-end in React, back-end in Fast API, Docker, Postgres, so basically typical setup. And as you can see here, this is how it worked. So it started with the product manager. And they decided the first step should be to do a backend. It transferred to the backend engineer, which performed some tasks. It created some code for us, a bunch of code, a bunch of text. Then at some point, it should transfer back to product manager. Over here. So it transfers back to product manager. And then product manager, as the next step, decides that it now needs to implement the front end. The agent responsible for the front end is kicking in, developing some code, a bunch of code as well. Again, at some point, it will also pass on to, I think, DevOps engineer. Let's see. Yeah, so then it passed on to DevOps engineer, essentially for creating the Docker Compose wrappers. Let's see, a bunch of text again, and then I'm not seeing QA engineer, so I guess in that run, it decided not to use, oh no, where? There it is, the QA engineer as well. So QA engineer was essentially decided to run the system, and it was testing the backend. Tested the backend. Okay, so looks like everything worked. It tested also the OpenAPI schema, did some integration tests. All right, and yeah, so did some performance testing. So again, I didn't instruct them to do so. They essentially, the product manager agent decided that it should be done. And yeah, there you go. So QA engineer also did some testing. And we can actually see the result of their work over here on, I think it was localhost 3000. So let me open this, localhost 3000. So this was basically the result of their work. Again, they've been running without any of my input or so on, or anything. The only input they got is this one on top of the page. Let me scroll this all the way up. Yeah, the only input they got is those 5 lines, essentially, right? So just create a website, 3 pages, React, Fast API, Docker, Postgres, and nothing much, right? So all the rest, they decided on their own. They decided what to test, how to test, and so on. And this is what they produced. So basically, let's see if everything works. So it looks like there are obviously maybe not the best design, but we also didn't ask them to create a good design there. We have a few talks, which I'm assuming came from QA engineer doing some tests. So it was able to submit the talks. It was able to, I guess, approve the talk. It actually created 6 submissions as part of the testing. So yeah, everything looks, well, again, maybe design is not the best, right? But yeah, I didn't have design agent there. So I would say as a sort of first iteration, it seems pretty good, right? And again, all I did is essentially 5 lines of prompt. Now, if you, on the other hand, yeah, and if you want to play around with this code, you can find it over here on this QR code. Let me make it a bit bigger. So you can find all the code here. You can play around, see how it behaves, and all you need is Anthropic's API key. And I think that's pretty much it. And then you will be able to create your own multi-agent systems. Although again, bear in mind that since they are undeterministic, it might be a bit harder to put them in production compared to just a simple demo which I had here. Now, on the other hand, if you don't want to spend time on creating your own multi-agent systems, but you want to leverage multi-agent systems, this is where essentially tools like us, like Encoder, comes in, all right? And we also have a bunch of agents which you can define on your own. So you don't need to do all this coding. You can just define your own custom agents. Here I have a bunch of custom agents shared with my colleagues, as you can see. And then you can use those agents as part of your CI/CD pipeline, for example, or inside your IDE. So in my case, I have, for example, this Jira ticket, which I set up in such a way that whenever I label the ticket, let me do this. Whenever I do this, whenever I label this ticket, now this will kick off an agent, one of the agents I have. And this agent will essentially just solve this ticket. So it should kick off, yeah, as you can see, it started solving the ticket. And we won't be waiting for it to finish. We will jump into this sort of result of the previous run. So it was able to solve the ticket for us. It produced the pull request. So that was the result of work of one agent. Now then, I have it set up that way. It's such a way that then, once the pull request is created, I have another agent that comes in with specific prompt, with specific tools, and it reviews the code. Right? So in this case, it found some issue in the Go client loader, and gave some suggestions, gave some comments. And then, of course, on top of that, I can also have yet another agent to basically address those comments, again, automatically based on the custom prompts, custom tools which I gave to that specific agent. So essentially, you get a sort of multi-agent system which you are in control, which you are coordinating, and kind of looking like this. So whenever both author and reviewer and then comment responder are essentially ChatGPT or Anthropic or whatever, and you are the developer, essentially just controlling or just maybe reviewing the code, or just seeing that they didn't go off, they solved the task correctly, and so on. So essentially, you're not already writing the code, you're just reviewing it. And then, of course, the next step is, again, comparing to self-driving cars. The next step would be level 5, where we have full driving automation. And essentially just a step further from level 4, from what you've just seen, from multi-agents, where they are starting to be on production performance level. They start to also interact with users, maybe, like collecting feedback, collecting requirements, and so on. Essentially, they are injected across the whole software development lifecycle. And then you, as developer, are just reviewing the code, just overseeing the progress, and maybe giving some suggestions to them, and so on. So essentially, at level 5, you're already probably not writing the code. It's pretty much like with self-driving cars. At level 5, you are not driving the car drives for you. And predictions are, as I've seen in the beginning, predictions are not something that usually comes to life in the time frame established. But I would imagine, given the current progress of AI and what we see in LLMs and agents, I would predict that we get to level 5 already by 2026, 2027, so pretty soon, right? And this kind of creates the question that pretty much developers might have only 2 years left with all those advancements. And you might have seen quite a few quotes from people saying that developers won't be replaced by AI, but they would be replaced by developers who use AI. And there is some truth to that, right? So because you, as developer, would be able to essentially command fully cross-functional agile team instead of focusing on your specific domain, right? So, for example, me as DevOps engineer, I'm creating my own personal website with agents, and I can read the TypeScript code. I can't write TypeScript code, but still I'm able to essentially create a website. I'm able to deploy it, obviously, as DevOps. But again, essentially, I'm commanding as a single person. I'm covering for the whole full stack team. But at the same time, you still need to understand what's going on. You can't just blindly, wipe code something and be done with it. You still need to understand what's going on. You still need to be able to read the code, and to avoid issues like this. So, wipe coding is fun, but then whenever you need to deploy it or whenever you get errors, it is becoming quite a pain to essentially make sure what's going on if you don't understand what's happening. And this essentially leads to our opinion as an encoder and my personal that and I think it is shared between multiple people, that AI will not replace developers, but it will transform the software development. Essentially, it will make developers more of reviewers or product managers, project managers, where we as developers would be, again, commanding an army of virtual engineers sort of across virtual cross-functional team. And then we ourselves would be able to focus either on more creative tasks, on more complex tasks. And again, pretty much like with the self-driving cars, we will sort of lose the job of maybe taxi drivers because the cars will be driving themselves. But at the same time, we will still have the jobs of maintaining the cars, creating the cars, and so on. So essentially, we would just see the sort of shift in skills compared to what we had before. And it won't completely discard the whole industry of cars, right? It will just transform it. The same will happen with AI in software development. But of course, if this fails, if you get replaced, there is still one job left. AI needs a lot of data, so somebody needs to create the data for AI to train on. So there is still this job left for you as well if all things fail. And with that, I have two QR codes for you, and the one on the, I think it's on the left on this side for you is for Zencoder if you want to try us out, and the one on that side is for my contact details. If you want to reach out, if you want to connect on LinkedIn, feel free to connect there.